quick overview of what we're going to do. So we're going to talk about version control systems and specifically Git. And then we'll look at the basics of Git. We'll also have an understanding of how branching works in Git, and then using Git and GitHub, and then any questions that might arise. So, onto version control systems and Git. So what's a version control system? So a version control system basically records changes to any set of files that exist in your directory, so that you can refer to the versions later. So you've seen this example where somebody would have a Word document, and then they would have Evans Dianga CV, and then Evans Dianga CV1, CV2, latest, and all that kind of stuff. And for a very long time, there are people who have been in that trap where you even name software files or code files as -1 or _1, _2, old, latest, and all that. But with the version control system, you're able to track the various stages, the history of the file from the point it was created up to the specific point in time that you are in. So you can always go back in time and look at a specific, look at the specific file at that specific point in time. So there are three, probably three main types of version control systems. We have one that is locally hosted. So you have a way of tracking the revision history within your computer within some sort of database. And then we have a centralized version control system. So this is where all the data and metadata about the revision histories are stored in a centralized server, and then various clients access it through a network of some sort. It could be internet or just a local area network. And then we have a distributed version control system, which we look at, which also is a very interesting version control system, in that each of the clients have the entire history of the whole repository whenever they check out that repository. So the difference between that and the centralized version control system is that in the centralized version control system, when you're offline, you can't commit changes back to the centralized server. But in the distributed version control system, you basically have the whole repository on your computer. You can make changes, do commits, and then at some point push your commits upstream to the main repository. Okay, so we look at a very brief history of Git. So how did Git come about? So Git was created by one of the luminaries within the computing society, Linus. And one of the things that led to the development of Git was that the Linux project, the Linux kernel project, used a distributed version control system known as BitKeeper. But then around 2005, the relationship between the community and the community that developed Linux kernel and the BitKeeper company went south, and so the ability for the Linux kernel team to continue using the BitKeeper distributed version control system for free was revoked. So that led to a headache for the Linux community. How would they now continue tracking their files and all those things? So they decided to create their own version control system. And because of that, Git was born. And so what were some of the goals of, that Git had? It was meant to be fast. The design was to be simple enough and support parallel branches, lots and lots of parallel branches at the same time, so that various people across the world could be able to develop on the Linux kernel specifically various features and not be hampered by the lack of support for parallel branches. And it would be fully distributed and able to handle large projects like the Linux kernel efficiently, owing to its speed and data size for all the commit histories and just the file history that it had accumulated throughout its entire existence. So that is how Git was born. And Git has become one of the most ubiquitous version control systems. And most people, when they think about version control, they equivocate that with Git. So the next thing we're going to look at is how do we think in Git? So in Git, as opposed to other file version control systems, it stores its data in form of snapshots and not deltas or changes. So some other version control systems track the individual changes that are happening to each and every file, and then track those deltas to be able to reconstruct the history of the file at any given point. But Git stores the whole snapshot of the whole repository at that given point in time, not just the one file, but the whole repository. And then most of the operations that happen in Git are local, so you can do them within your computer without depending on any network connectivity. Another thing that Git has is referential integrity, because they use SHA-1 hash, which is helpful in ensuring that all the files and every piece of information that is stored within Git is referenced, not from any other source, but based on the contents of the file using that checksum. And it's mainly append operations. So as you go through your Git commits and all that, which we look at, you're basically adding to the history of the files and the history of the repo. And that means that at any given point in time, you could go back and recreate your repository at a specific point in time. So next, so what are the states in Git? So Git, any file in Git exists in 3 states. So one, it could be unmodified, modified, or staged. So when it is unmodified, that means it has already been committed and it is stored within the database and it's safe. Modified means that you have changed the file, but you have not yet committed it to the database. And staged means that you have marked it as modified and it will go to the next commit. We'll look at that in depth. So there are 2 ways to use Git. You can use the user interface or a command line interface. So we have a graphical user interface rather, and a command line interface. So a graphical user interface for Git exists. One of the best known ones is GitHub Desktop, and I think it's available across all platforms. And there are many other clients that provide the same functionality, GUI functionality. So installing I think for most Linux distributions, Git is pre-installed. I think even in Mac OS. But installing Git should be easy. You should be able to find the instructions online. But one of the hacks for Windows is that you can install GitHub Desktop, and then it will come with the full-blown Git in your machine. So I'll be able to show the examples of both using the graphical user interface and the CLI. So how do you get help when you're stuck in Git? So You can use the full manual. I'll just demonstrate that. Either using the get help and then the verb. So if you want to get help on adding files, you'd probably do get help add or get help commit, and that will give you the manual. Or you could do the man get and then the verb. So if you want to look at all the available options for a specific command, you'd write the command and then you do a dash h. So I'll be able to show that just quickly. So you can do get help. Okay, should I increase the font of my terminal, the font size, or okay? Let me do that, and let me see. Let me have feedback if it's okay. Is that good enough? Okay, so you can do get help. Sorry, get help. Get help. So you see, so it will give you the manual. So it tells you the name, add file contents to the index, and then it gives you all the various flags that exist. It gives you the description and all that. Looks like it's opened up in Vim, and so the classical question of how do you exit Vim, and you do a queue. So, or alternatively, you could do a man get add, basically the same thing. Or alternatively, we can do a get add dash h. So it tells you the various options that exist for that command. So yeah, you can do it in interactive mode and all those other things. So if you're ever stuck, you could go online, but if you're not online, you could basically use this get add get and then the command and then the flag dash h. So we'll continue. Okay. Okay. So how do we configure Git? So there are 3 places where Git looks for configuration files. So the first one is, especially if you're on Linux, /etc/git-config. That is the system-wide. That is the system-wide config, and the thing is that it affects all the users across the whole computer or across the whole system. And then the next one, this applies specifically to you. These are the config files. This is where all the options for a specific user are stored. Basically, it is in home.git-config or home.config/git/config. And then lastly, we have a .config which exists .git/config which exists within a specific repository. So how does this work? So the first place Git looks is the etc/config/git-config. Then the next one is this, and then the last one is this. So in terms of the order, the user specific, the repository specific settings take precedence over the user settings and over the global settings. So if you define something in /etc git-config, and the same flag, the same property is also declared in .git/config of the repository, the one of the repository takes precedence. I don't know if that is clear. If it's clear, that just let me know. Okay. Okay. So, and then the next thing is, how do you set your identity? So once you've installed Git, the next thing you'll just run this commands, git config -- global. This will affect the global configuration. and then user.name, user.email, and then you've probably encountered this the Vim versus Emacs. So if you're a real Emacs person and you don't want to use Vim or VI, you can change the editor that Git uses when you're doing things like writing commits, merge conflict resolution and all that. You could do the core.editor to change it to Emacs, and there are probably Windows specific commands here, but you can probably check that out. This is mainly on Unix systems, specifically Mac and any Linux variant. And if you want to view all the configs, you can do git config --list, and we'll show that again. Git config --list. So yeah, so yeah, so my current, so that's my current configuration. So continuing. Okay. So where are we currently? So let's look at the next thing. So we've looked at version control systems and Git, and now we're going to look at Git basics. So that's the next thing on our radar. So here we're going to look at how do you get a repository, how do you record changes to the repo, how do you look at the commit history, how do you work with remotes, we'll understand what remotes are, and aliases, what do those even mean. So getting a repo. So there are two ways. The first one is if you want to initialize Git in an existing folder or directory. So assuming you have this folder and you want to start tracking files in it, so we'll just do a git init, and if the directory is not empty, you should begin tracking the files by adding and all of that. So let me do this. So let me just create some empty directory. So I'll just create. Okay, sorry. So I'll make the directory and call it Ubunifu, and then I'd like to, yeah, so I'll create the directory and then change the directory there. So yes, so assuming this is the directory, so for those who probably are wondering, this is just, I've changed directory to projects and then made a directory called, or a folder called Ubunifu, and then did a change directory to the last, to the response of the last command. So that is Ubunifu. So I've changed directory. So this is just a shortcut of to Ubunifu. So if I wanted to do an initialization of Git, I'll do git init, and then so it will tell me it has initialized an empty Git repository there. So that is the first way you could do that. So by so I've initialized an empty Git repository at /ubunifu. So what's the next thing that we could be doing now? So the next thing is probably, how do we clone an existing repository? How do we get a repository that already exists and start committing changes to it? So there are a couple of ways. You can do a git clone and then the URL, and then or a variant of that will be you add a directory name. So what are the difference between those two variants? So this one, git clone URL, will take the repository name, will clone the repository into a folder bearing the repository name. But git clone URL slash and then the option of the directory will create the repository into the directory that you've given, and then git clone URL and then a period will clone the repository into the current directory that you are in. Let me show the three variants. So you'll forgive me. I'll try to clone the repository for my blog and show that. So okay.
Maybe the manual.
Yeah.
Because I don't see how this whole word somebody has a similar name. Is that really possible?
Okay, I didn't get you.
Hijacking. Why hijack for what?
Okay. I don't get. If you're asking something, please just type it onto the Skype. I can't get you. So what I'll do then next is so I want to clone this. So let me just create so let me do that. So what I'll do next is I'll show the first variant where I'll just git clone and then the URL. So it will tell me it's cloning into evansdianga.com, and if you look, there's a folder called evansdianga.com. So that is when I use a git clone and the URL without specifying the folder, it will clone the repository into a folder bearing the name of the repository. Another option would be to do the same, a git clone URL, and then specify a folder name. Let me say new blog. So that is going to be the new folder name. And yes, and as you can probably see, there are already two. This is the first one that we created using the first variant, the second variant, and then the final one. So I'll create a directory and say, okay, blog, and then I'll change the directory into that. And so I'll do a git clone, and then I'll do that. Okay, oh, sorry. Yeah, so it will clone. So what happened is that in the previous command, I supplied two arguments, new blog and a period, which just stands for the current directory, and that was invalid. So as you can, so let me go back a directory, and you can see the three repos cloned here. I don't know if anyone has any question. So those are the three ways you can clone a repo into your machine. So one, either to a repository bearing the repository name. Okay, I'm seeing a question here. Okay, so oh sorry, I hadn't been seeing the questions, so I'll be tracking them. So one is that the GitHub desktop, when I was doing the man and then the help for that specific command, it was not GitHub desktop. That was just from the command line interface, and it was using my Vim. So how can we make Git continue in case internet breaks and you need to continue from where you are? I'm not sure about that. I don't know if anyone has an experience with that when you're trying to clone a repository and then it doesn't finish cloning. Unfortunately, I haven't experienced that. So if anyone has an answer to that, I think that would be great. So, okay, I'll continue. I see Steve is typing. Okay, thank you so much, Steven. So let's continue. So, so there are two transfer protocols. So there's SSH and HTTPS. So SSH is my preferred way of doing that, because most of the times when you use HTTPS, it requires a username and password, and most of the times I'm too lazy to enter username and password. And when I'm using SSH, it may require a passphrase if you set up your SSH keys to require a passphrase. So I don't know if we'll have time, but if we have time, we'll probably look at how to do both of those. So, and the difference comes here. When I was cloning this, I had the option of either using HTTPS or using SSH. So if you for any reason you can't use SSH, you could just come here and clone using HTTPS, and Git still accepts those protocols. Okay, so how do you record changes in Git? So there are two file states: tracked and untracked. Tracked means the file has already been added to the repository, and Git now is tracking it. But if it is untracked, it basically means it is in the working directory, or in the tree, rather in the working tree, but Git does not have any idea about it in terms of being committed to the database to be tracked. And once a file has been submitted to be tracked, it can be in the three stages that we talked about: unmodified, modified, or staged. So how do you record changes? First, to check for the status of your files, you do a git status, and to track new files, you can do a git add, and then plus the file path. Okay, so I'll answer that question next. So if you want to track new files, you just do a git add and then the file path. I'll show how you do that, and then you can also do a git add.period that adds all the files that are currently untracked in that repository to be tracked. So let's do that. And just quickly, as I answer Lonalo, is SSH normally one time, and what happens when you change the device? So when you create an SSH key, they are stored with, so you have two things. You have a public key and a private key. So the private key resides within your computer. The public key is the one which you add to GitHub. When you change your computer or you change your device, you have to create a new SSH key for that device that you have, and then add the SSH key to GitHub or to the server which you are using Git from, because at times you might not be using GitHub, you might be using Bitbucket or a locally hosted solution. Okay, so let's do something with the things that we just did. So okay, so okay, so let me just open that, and then I'll show you how to do the git adds and all that very quickly. So sorry, okay, I could just still do very quickly. So what we can do is, so the first thing is that we talked about is looking at the status of your files. So currently we've just pulled this from GitHub. So when you do a git status, oh, sorry, cd blog. Okay, okay. So so you're probably seeing it's telling me that I'm on the branch master. This is not a feature of Git. This is the feature of the shell that I'm using. It's called omyzsh. I'll type that to Skype so that you can. It's a very, very wonderful extension. So omyzsh. So if you use it, it will always tell you the current branch you are on, and I can do quick things like that, and then it will. That is an alias for git status. Okay, you should probably check it out. So git status, and then it will tell me your branch is up to date with origin master. There's nothing to commit, it's clean. So assuming I created a file, and then I said so when I do a git status, it will tell me this file is untracked. So I have two options. I can either do a git add and then ubunifu. If I do, oh sorry, git add ubunifu.md. If I do that and I do a git status, you'll see it's already staged and it's ready to be committed. So assuming I add another file, so that's just a markdown file. So if I did a git status, you'll see that we have two. So there's this one that is ready to be committed. There's this one that is untracked. But if I do a git add and then dot, it will add everything that is currently untracked to the tracking. So when I do that and I do a git status, you see both of them are ready to be committed. So let's continue very, very quickly. So another thing that would, so that is how we track new files, how we add them to be tracked. And then the next thing probably want to look at is how do you stage modified files? So assuming I'd committed these files, so let me just commit, and we're going to look at how to do the git commits. And this is not a good example of writing commits. Okay. And that's a good one. I'll tell you what that is. So please, at the end of the presentation, if I don't mention this, just remind me about this GPG, how to do commit signing. Okay, and I can't remember my passphrase. Okay, yes, I did remember. So I've committed that. So assuming I change content in Ubunifu and then I say it's something like title. So I've added obviously content to ubunifu.md and I've added the word title. I should be using a real editor so that it can be helpful for those who are not very familiar with Vim or such. So you see, this is what I did. This is what I added. I added title there. So when you come and look at this, so we expect that there are changes in Ubunifu that are not yet added to the staging. So if you do a git status, git status. So we are told that it's modified ubunifu.md. So we can do two things. We can add the how we can add the changes to the staging is either to do a git add and then ubunifu.md, which we had already seen. But another cool way that I'd want to show you is that git add and then -p and then ubunifu.md. So a -p flag basically is it means patch. So it will allow you to change to select the changes that you want to make interactively. So when I do that, so you see, it tells you there's the initial ubunifu and there's this ubunifu. So what is the change I've added, and what have I added? It's this guy here. So if I do that, if I do a yes, it will add it to the staging. But how about, think about if I'd done, so if I do a get status, now it will say it is ready to be committed. But how about if I had done this? So let me add something. Subtitle, and then I delete that, and then I say some random text. So, and then I do a git add with the flag patch. So it will ask me to decide if I want to accept that or not. If I do an N, it will reject all that. But if I accept yes, it will stage all that. So what this helps with is it allows you to specifically pick which commits you want to include, which changes you want to be staged in the next commit. I hope that is clear. If somebody has any question on that, I'll be very much willing to clarify further. So another quick one. So we'll go back to the presentation. So a very quick one now is how do you ignore files? Assuming you have all these files that you want to exist in your repository, but you don't want them to be tracked by Git. So that might include things like you have some secrets, you have some specific configurations, and you have some specific configurations that you want to exist on a specific machine, but you don't want to share with the other developers, or you don't want to push them upstream. That is where you use something like a .ignore file. So a .ignore file, you put it at the root of your repository. Let me show you how that looks. So a .ignore file. So let me increase my font size. Okay, and let me know if the font size is okay for you guys. So so this is my .ignore file. So for those of you who are conversant with JavaScript ecosystem, this node modules folder, I haven't installed it. So there's a node modules folder when you're writing JavaScript and you're adding a lot of modules. This node module folder stores all the packages that you have, and you don't want to check that into version control, because you can always pull them from somewhere else. And since I don't want that to be committed, I add that folder into the git ignore. And then this is something that is specific mainly to Mac. And then I don't want this file also to be committed, this folder, and all these files, the cache also, the folder rather, the cache folder, and also the yarn.lock. I don't want it to be committed. If I didn't want this package lock.json to be there, I'll just do package lock.json, and then it will not be tracked from henceforth. So that is how you ignore files. If you have in Python, if you have that folder pycache, and you don't want it to be tracked, I think that is one of the best places to use it. So how do you specify that? You can use a glob pattern. You can check that out online. And then there are examples on how to use Gitignore. There are starters for various languages. And as you can probably see, and that is taking its sweet time. Yeah, so there are various for various languages and for various setups. So you can always just come here and start from here if you don't know what to exclude. Okay, and there was a question. Oh, so I said, oh, sorry. When I said that is when I was writing the commit message, what I meant is that my commit message is not the best commit message. You should probably write a more descriptive commit message. My commit message was so funny. So let me look at the commit message. Okay. Is it a double M? Okay, I don't know. Okay, yeah. Okay, thank you. So, okay. Oh, I know what I wanted to do. So git commit dash amend. Okay, I don't know what's happening. Okay, thank you. Okay, and I'm having spelling mistakes everywhere. Yeah, so you see, okay. You see, what was this was my description for the commit, and it was not very descriptive. Some files added. You'd probably want something more descriptive. And thanks for that. So very quickly, we're almost getting to the place where we're done. So, and to view stage changes, you can always do this. You can do a git diff, and then if you want to look at the changes which have been staged, you can do a git diff dash stage. So how do you record changes? You can do a git commit, and then you can do a git commit -m and then commit message, or git commit -a-m commit message. So I'll quickly show how those three variants work. So to our very sweet Ubunifu, okay. So we'll come and go here and say just some random thing there, and then come down and then say git. So I'll show the first one. So git commit. So first a git status. It shows that this is modified, both Ubunifu and Gitignore, but they are not staged for commit. But you remember, if you do a git diff -- staged, my spelling is awful. Sorry. Looks okay. Looks like I don't have any diff. So, assuming I wanted to add this and commit at the same time, I'll do a git add, not git add, git commit -a-m, and then I'll add my commit message and say something cool. So what that does is that it does the git add for us, git add the file name, for us, or it does the git add -that. So because we only had one file, it did the git add ubunifu.md. But if you had so many files, it would do all that for all that. And I think that is what it has done. Because you see now our Gitignore and Ubunifu have been added to the commit. So if you wanted to be a little bit more picky, and let's delete that, and you wanted to go through a longer process, you can do a git add ubunifu, and then you can do git commit. If you do a git commit, it will open your default editor, and then you'll enter the commit message. But if that is a longer route, what you can do is git commit -m, and this will add the commit message to all the files that are currently staged. So if you do some other commit, it will add it there. So the git commit -a-m, what it basically does, git commit -a-m, what it does, it adds all the files that are being tracked to staging, and then it creates a commit message with a string that you'll provide, and then it adds them. So I hope that is clear. Okay, and removing files, you just do git rm file name. So you do the rm file name, just removing it like you remove a Linux file, a file on Unix rather, and then you do a git rm with the file name. So this is the one that I'd want to show, git rm -- cached. So assuming we want to remove ubunifu from being tracked by Git, but we want to have it in our working tree. We still want it to appear within our file system. What will we do? We'll do a git rm -- cached, and then ubunifu. So what happens then is that you see it's deleted already. So when we commit it next, it will not be tracked. So that is how you remove it from being tracked, but still allow it to remain within your repository. But if you just do a git rm, it will remove it also from your folder, or from your file system rather. So okay, let's do this quick ones. So how do you list commits in reverse chronological order? You just do a git log, and if you want them in a prettier format, you do --1 line. So let me show how that works. Okay, thanks. So git log. Okay. So this shows you all the things that I've been committing. You see, this is all the commit histories for this repository that I pulled from GitHub. But if I wanted to do that, I want to make it pretty. I'll do 1 line. So I'll just be seeing the commit hash and what the commit message was. I think that is more readable. Yeah, and then finally, the one which is probably of interest also, assuming you have written a commit, but then you realize you either made some mistakes in the commit, and you'd want to edit the commit message. So you do a git commit, and this always trips me. The spelling for amend, it's a single M, and so you see this is the last commit. So what we'll do is, if I do that and I change that, I can change the commit to say some new commit, and with that I have changed my older commit message to this new commit message. And that would also work if you had done a commit, but you also needed to add some files. So assuming the way we had deleted this ubunifu, but we realized that there was a file that we needed to have added to the previous commit. So you just add that commit, and then you do a git amend, and then it will allow you to add that to the previous commit and join them together. So we are almost done now. So okay, remotes. So how do you work with remotes? So remotes basically are where our files are hosted and all that. So if you want to see the URL for where this is, where this points to, so get remote -v. So it tells us that it is at GitHub and all that. If I just want to see the short name, so this is the remote short name, I'll just do a get remote. And it will tell me it is origin. So whenever I'll be pushing, I'll be doing something like a git push origin and then the remote name. So so if you want to add a remote, assuming this, I will just initialize this empty repository, but we didn't have this already added. We could do, or let me just do this. So if you wanted to add a remote, so what we'll do is get remote add, and then I'll add the short name. So let me say new origin, and then that. So when I do that, so when I do a get remote -v, you see new origin is that. So that is how you add a new remote. If you wanted this, for example, to point to new origin to point to Bitbucket, you would add the URL to Bitbucket, and then when you wanted to push to Bitbucket, we'll just do a get push new origin, and then it will always go to that. I hope that is clear. So that allows you to work with various remotes from the same repository. And then there's the last thing that I want to talk about there is fetching and pulling. If you want to get all the references and the history of this repository, you can just do a git fetch. This will not change anything on your file system. It will just take all the references and all the histories and just add them to the current repository. And then if you want to do even a faster one, or a faster one, you'll do a git pull. So what a git pull does is that it goes to the origin, gets fetches all the history, and then merges the branch, the remote branch, to the local branch. So instead of doing git fetch and then git merge and then origin master, I'd probably just do a git pull, and then that would be very, very helpful. I don't know if there are any questions. We are also almost short of time, so I think I'll skip that. That's a little bit advanced. And then so finally, branching in Git. I think we've sort of touched about that, but I'll just mention it very quickly. So how do you create a new branch? Let me show that quickly. How do you create a new branch? So you just do a git branch and then the branch name. So let me say new branch. So what a new branch does is that, okay, that's not a very good name. Let me say add title. So what this does is that it copies the current snapshot of the master or the current branch that you are in, and it gives you a new sort of workspace to work in. So when I do that, it has added the branch, but I have not switched to it. If I wanted to switch to that branch, I'll just do a git checkout add title. And then it will tell me I've switched to that. But if I wanted to create a new branch and switch to it immediately, I'll just do a git checkout -b and then add another. Yeah, and you see it has switched to that. Okay, so finally, Git and GitHub. This should be easy. So so I'm just going to briefly describe how you work with Git and GitHub. GitHub, I think, is one of the most used sites by computer programmers because of its ability to host projects for free, and now they even allow you to host private repositories for free within your GitHub account, provided you have, I think, less than 3 collaborators within that. So ideally, when you have created a GitHub account, you'd want to set up your computer to either work with HTTPS, which is the default probably, or SSH, which I would highly recommend. And then Another thing, once you have set up your GitHub account, that I would really encourage is setting up two-factor authentication that will allow you to avert any security threats when people try to steal your passwords and gain access to your account. So I'll quickly show how to create a project and then add collaborators and all that kind of stuff. And then I'll take your questions. So I'll do that. So when you've logged into your GitHub account, you can always come here and then say new repository. Okay, so when you create a new repository, it will ask you the repository name. I can write Ubunifu. I can choose the description. I can decide whether it's public, then anyone can see it, but I choose who commits. But if I put it as private, only those who I have invited will be able to see it. So I'll put it as private, and then we'll talk about the .ignore, the license, and the README. So the README basically is a file that allows people to understand what your project is all about. And then the .ignore file, we talk about it. And to add a license, this is very important, especially for open source projects. Most people won't contribute to your project unless they know for a surety that the license is permissive and they'll not enter into any legal problems. So it's always good to have a license, whether it's any of this, and you can always have a short understanding of what each of those license types mean. And with each project and each license type, that determines how the code can be used and who can use it and how you make changes and who own the changes and things like that. So I'll create this repository and then show how to add collaborators quickly. So how do you add collaborators? Just go to settings. Okay, and then collaborators. Okay, I have to confirm my password. So, and then I can add Lunalo, I think is the one. Lunalo, what's, yeah, I think that's, yeah, so I can add the collaborator. So right now, if Lunalo accepts, he can start collaborating, but others cannot access. Even if you have this URL, you cannot access this repository. And then on that, I'll just go back. So another thing that I'll talk about is, okay. So another thing I'll talk about is what is called an issue template or PR template and all those things. So a pull request template basically shows that it's a template. When somebody either wants to put in a pull request, they'll have to enter they'll have to enter things in this kind of format. So it gives them a template from which they can work from in terms of creating a pull request. And we have for issues, we have for pull request, and we have for various other things. And yes, so finally we come to, I know I really rushed through that part of that section, but we can always talk about that PR and how do you do pull requests and all that. So are there any questions? Okay. Is it possible to create a pull request from the Git command line? Yes, it should be. You should be able to do that, but I'm not. I basically I never do that from the command line. What I usually do is that once I have pushed my commit upstream, the command line basically gives me a link to create a pull request. So I usually just control click it and then, or command click it for Mac, and then it takes me to the place where I add the pull request. So that is how I usually go about it. But definitely you can do that. Okay, any other question? Okay. Yeah, so I'll assume there's no other question. And thanks so much. And So credits, I was able to create the presentation using Canva. Most of the notes I took from program, and then also helped colleagues and you guys for making it a success. And